Hi, this is Aaron Lewis from Franklin Maths. This is the first lesson on normal distribution. There should be an attached worksheet with it on the Google Classroom. So, what we looked at in the first year was the binomial distribution. Now, the binomial distribution was based on discrete data, and that's where data has steps in. So it could be shoe sizes, it could be colour of things, lots and lots of examples of discrete data around. So just taking shoe size as an example, this data is completely made up, by the way. You can be a size 1, you can be a size 1.5, 2, 2.5, 3, 3.5, etc. And that's it. You just get shoes to sort of fit your size. You don't have made to measure shoes, and if you did, they would be quite expensive. Okay. The question is, what about if we want to look at, instead of this being discrete, is to make this continuous? Well, we'd need a different sort of distribution. So this is the normal distribution. So this time I'm using continuous data. So I've based it on the previous bit of data. So I've converted size 7 into centimeters. And again, it was completely made up data. So don't worry about this actually meaning anything. This isn't fact or anything. So if I look at, say, this point here, this could be 16.59732, as many decimal places alike. So it's continuous. It can be anything. Okay, and anything which is measured in sort of mass, speed, length of things is continuous. It's very hard to measure something exactly. So this is where the normal distribution comes in. So this is basically what the normal distribution curve looks like. It has this lovely sort of bell shape to it, what's known as a bell curve. So in the middle here, and it is symmetrical around this, this is the mean. I know in the first year sometimes we used x bar for mean, but in this case here we're going to use mu. And then next to it we've got sigma, or lowercase sigma. And that is the standard deviation. Now remember from the first year, the standard deviation is just a measure of spread. Okay, and I'm just going to draw a line up from here. Again, please be neater than me if you're copying this. And I'm going to do one there. Now, a couple of important points. We know the exam board are quite picky with certain things, and they love to catch students out. So this is worth noting. This point here and this point here, these are inflection points. On from your pure work, this is where the graph goes from. So this is where the graph here is convex, and this bit of the graph here is concave. Okay, so remember, reflection point is that change in convex to concave. Okay, the exam board do like to do this. They will give you one of these and go, well, this is 14 here. Or they might give you the state of an inflection point and say, well, what's roughly the standard deviation? I have seen it before. You've got to sort of guess it. Now, this area here in red, this captures, and we did sort of mention this in the first year, 67, around 2/3 of the data, about 67% of the data. So it's a fair chunk of the data. Whereas, say, the interquartile range only captures 15, and that can be skewed. And from there, this time, if I look at, just change my pen color a second. If I look at 2 standard deviations away from the mean, so this bit here and this bit here, there's nothing about inflection points in this. You can see that this is more area. Feel free to make really nice copies of this. It does help in the exam to sketch normal distribution curves. The examiner will be looking for that. If you've got a graphical calculator, you can just take it from there. If you haven't got a graphical, this is slightly harder to do. So the blue area this time, the chance of finding somebody in the blue area is around 95%. So it is a fair whack of the data. Okay, and the final bit of this is what about happens if I go to 3 standard deviations. So as you can see from the graph, it is pretty much all of it. It's everything that you can see. Please colour better than me. Make a copy of this. I would tend to do 3 separate diagrams in my notes rather than try and draw all over the top of each other. It's just easier in terms of workload on your mind to have the 3 separate diagrams. So this here, do you reckon it captures? 99.7%. So if you're outside 3 standard deviations away from the mean, you can say, well, there's a very slim chance of it happening. Okay, we've got a couple of summary slides here. So that's what we've looked at before, and this is what we looked at before here over on the right. But this is quite important here, that with a norm distribution, the mean, the mode, and the median are roughly the same value. It is symmetrical, and these are the bits we've looked at before in terms of inflection points. Now the way it's written in your exam, it's just sort of like, it is like the binomial in the way it's written. Because we are using distribution, you have to sort of state the distribution before you start. X is your variable. Tilde means is approximated by. And we've got the n for normal distribution. And here we've got the mean. And here we've got sigma squared rather than sigma. Now remember from the first year, sigma squared is variance. So whenever you work on this, you've got to square root that value there. But I'll go through an example of how you should work that. Okay, so here's my example. So you've got x, whatever x is, I don't know what this is, it's just made up data, is approximated by the norm distribution. And I would always in my exam just jot here what the bits and pieces are. So mu is 10, sigma squared is equal to 4, so therefore sigma must be equal to 2. Now the reason we're taking the positive root rather than the negative root, it actually doesn't matter, because if we're going to add on a standard deviation, we're going to add on -2, well we're going to end up at 8, and if we're going to -2, we're going to end up on 12. And you can see, look, between 8 and 12, I'm capturing 67% of the data approximately. I've got an inflection point there, and between 6 and 14 I've got 95% of the data, and between 4 and 16 I've got 99.7% of the data. If I go outside those values, so the chance of me getting 1, extremely slim, which is why this is used for hypothesis test. Okay, so here is a example for you. Feel free to pause the video, jot this down, or you can watch me do it first and then copy it down afterwards. Just get my pen on again. So first thing we're going to do is begin to state the parameters for this one. So, and what we're using, which distribution. Now height, it won't be binomial because you can be any height in terms of centimeters. So you we will be using the norm distribution. So what we're going to do is say let x be the height of a town resident. Oh, sorry, a city resident. Now I know some of you took the course because you don't like writing, but it's worthwhile marking the example just for stating sort of the rules again before we start. So what I'm going to do now is I'm going to jot down what mu is. So mu is 182. Doesn't really need any units at this moment in time. And the standard deviation is then equal to 4. And so then I'm going to write down sigma squared. I'm just going to fall into that habit all the time. So x is approximated by the norm distribution. And it's the mean and sigma squared. Okay, easy enough to do. And so for the next question, I'm quickly just going to jot that down. So x, not sure what's happened to that line there. Let me just quickly delete that. So x, so tilde, and it was 182, comma 16, and we know that mu is 182, and sigma is equal to 4. Okay, so what we want to calculate, just reading the question, there's a probability that this person is more than 175, but less than 190. So the actual formula, because this is an integration problem, because the area beneath the curve gives you the probability, very difficult to work with. So we will be using the calculator. So if you have a look here, if I go to menu, so you guys have something like that. Now if you go across to statistics and just press exit there, so you guys will get something that looks like this. We did use this in the first year. So if you go to dist, go to norm for normal. Now we're going to be using NCD because we wanted to add the probabilities together. And we're not using a list. This isn't a list of data. This is just variables. So we're going to press F2 for variables. And what we're going to do is our lower value is going to be 175. Our upper value is going to be 190. Our sigma was 4. And mu was 182. And then if you just go down, so make sure you just press the execute button down here, or so you can say it's equals. Doesn't really matter. Change the color of your graph if you really want, but nobody's got time in the exam to do that. Now my advice here would be always to draw it, which your calculator will do, and get that drawing down on your notes. So you can see here that this gives you a probability, an answer of 0. Just delete that a second. And it gives us a probability of 0.9372. So 0.9372. Easy enough to do on your calculator. Okay. And the worksheet is, there's plenty of practice of that. So the next one then is this time the probability that somebody is less than x is less than 180. So I'm going to attempt to draw it, just a quick little sketch so you can see what I'm thinking about here. There we go. So my curve looks something like this. Apologies, it's not great, but you get the general idea. You've got the mean there at 182, and what we want is everybody's less than 180. So it's everybody there, and obviously this goes on forever, infinity. But what we do know, so it's a negative infinity, what we do know is that there's less and less chance of happening. So we just need to choose a number which is quite far below 182, maybe minus a million, minus 1,000. So again, we're going to dive back in the calculator. So we're going to press exit. We're using the same values again. We just need to change the upper and lower. So my lower, I'm going to choose as minus 100 because that's absolutely miles away from the mean. And the upper I'm going to choose as 180. You can always choose your lower there is like more than is 3 standard deviations away. It will give you roughly the same answer. Press execute. So that's me press execute twice. It's given the probability, but I would always go back and get it to draw it. The examiner will want to see the drawings of it. So this is 0.3085. 0.3085. It is fairly easy to do with it, with a graphical calculator. Without graphical, this is quite tricky to do. So this is my next example here. Again, we've got the distribution written down. So you can see this time what we're going to do this time. You can approach this again with your calculator, but remember this is pure work coming back in. So g minus 18. Remember, if it's a less than, you get a sort of connected inequality because it's all about distance. So this is going to be g minus 18 is between 4 and minus 4. Remember, if it was a greater than, I get 2 separate inequalities. Again, that is covered all in the modulus part of the course. So this time, so g is between, add 18 to both sides, so 22 and 14, and then bung that through my calculator. Okay, I haven't given you the answer for that one, but I just need to give you the workings there because it's not too difficult to work with. It's just the fact that you need to be looking at this similarly. If it's a greater than 2 separate inequalities, it's a less than, it's connected inequality. And then from there, I would like you to do just question 1 from exercise 21A. Thank you.